Inside a billion-dollar hydropower turbine, a hidden cooling network is the only thing preventing a catastrophic melting meltdown. The turbine bearings support thousands of tons of rotating mass, and they generate enough heat to liquefy steel in minutes. The massive generator could destroy itself, bearing would overheat, lubricating oil would break down, generator insulation could fail, and within minutes, a $1 billion hydropower unit could trip completely offline. So, how do engineers keep these giant machines alive 24 hours a day for decades? The answer is a hidden engineering network called the cooling water system, and today I will show you exactly how it works. While it is easy to assume that being surrounded by thousands of gallons of rushing water keeps a hydropower generator chilled, the reality is far more intense. Inside the powerhouse, these machines are actually battling massive amount of internal heat. The generator, bearings, oil system, and rotating shaft create enormous heat continuously. And heat comes from mechanical friction, electrical losses, rotating oil systems, shaft movement, air circulation inside the generator, and the turbine shaft alone can weigh hundreds of tons. And all that weight is supported by bearings rotating continuously. Without cooling, these bearings would literally cook themselves. Even the generator winding became dangerously hot because of electrical current, and that's why every major hydropower plant uses a dedicated cooling system. Think of it like a car radiator, except this radiator cools a machine that is the size of a building. Okay, now at first, using river water for cooling sounds simple. Just pump cold river water into the machine, problem solved. Except there is one massive problem. River water is dirty. It contains sand, silt, mud, stones, biological particles, floating debris, and if that dirty water enters sensitive equipment, it can destroy the entire cooling system. It would choke narrow cooling passages, damage pumps, block heat exchanger, and contaminate bearing coolers. So engineers created a genius solution. Instead of using one cooling system, hydropower plant use two completely separate water circuits, an open loop and a closed loop. So this is the secret behind the entire system. Okay, now, the open loop uses raw water or tailorless water. Its only job is to remove heat from the system. After absorbing heat, the water gets discharged back to the tailorless. Simple. But the closed loop is different. This loop contains clean, treated water. This clean water never mixes with river water. Instead, it circulates continuously inside the powerhouse, cooling sensitive equipment safely. So the real engineering trick is that dirty river water remove heat from clean cooling water without the two water even touching each other. And the machine that make this possible is called the heat exchanger. So this is the most important component in the entire cooling system. The plate heat exchanger, think of it like two highways of water separated by thin metal plates. On one side, hot, clean cooling water arrive from the generator and the bearings, and the other side, cold river water flows from the open loop. Passes through the metal plates, but the water never mixes. The dirty river water carries the heat away, and the clean water becomes cold again, ready to cool the machine once more. This process repeats continuously every second while the units operate. Now, uh, let let's follow the complete path of the cooling water. Step one is cold water is taken from the tail race or reservoir. This becomes the open loop water, but before entering the system, it passes through manual standards. This remove leaves, stones, large debris, and next is the open loop pump. Increases water pressure and circulates the water. Usually, one pump run continuously while another remains on standby. After the pump, water passes through automatic standards. These remove small particles and protect the heat exchanger from choking. Now, the cold raw water finally enters the heat exchanger. At the same time, hot closed loop water arrives from the generator equipment. Heat transfer through the plate, the raw water becomes hot and get discharged back to the terrace. But the closed loop water continuously circulate inside the powerhouse, and this is where the real cooling happens. The closed loop water now flows towards the most critical parts of the hydropower unit. First, the generator air cooler. Inside the generator, electrical losses create huge heat. Cooling water removes heat from circulating generator air to protect stator insulation. Next, the thrust bearing oil cooler. This bearing carries the entire vertical weight of the turbine generator shaft, and that load can reach hundred of tons. Without cooling, bearing oil temperature would rise rapidly. Then comes the upper guide bearing. Its job is to stabilize the upper rotating shaft. Then the lower guide bearing, and finally the turbine guide bearing near the turbine side. Each one produces heat continuously. The cooling water absorb heat from all the system and return hot to the heat exchanger, where the entire cycle starts again over and over, 24 hour day, sometime for decades. But what happens if cooling suddenly fail? This is where the protection system become critical, because sensors continuously monitor water pressure, temperature sensors monitor bearing temperature, cooling water temperature, generator cooling performance, and if temperature rises too high, alarm activate immediately. If cooling pressure drops dangerously low, the unit may automatically trip to prevent catastrophic damage. And if the main cooling pump fails, the standby pump starts automatically within seconds. Even the stanners are monitored for blockage, because one blockage line can threat the entire hydropower unit. So the next time you see a giant hydropower generator producing electricity, remember this. Behind all that power, this is a hidden cooling system quietly fighting heat every second. Without it, the generator could never survive. No cooling system means no safe operation, no reliability, and no power generation. It is one of the most important yet least visible system inside a hydropower plant. And now you know exactly how it works. So if you enjoy real world hydropower engineering explained in simple language, subscribe to Hydrovision, because in the next video we will go deeper inside the hidden system that keep these giant machines alive.